Okay, did you get a look at all of them? Okay. If you graph these things, we're just going to talk about them lightly today, but here's what you're going to be thinking for the rest of the time. Let's start with the parent function, 1 over x. If you graph that, it should have looked like this. Okay. Do you see that there are two asymptotes there? Yeah. There's a horizontal one. And there's a vertical one. Somebody make sense, connect the graph to the function. Why is there a vertical asymptote at x equals 0? Why is there a vertical asymptote at x equals 0? X equals 0. Why do you think the graph is avoiding that? Connect this to this. Yep.
Because no matter what value you divide one by, you won't get to 0.
Right, because why? Because why? Why do you think we cannot get 0 on this? You guys are kind of playing around it, which is what this function is doing. Funny. What can't you input here? What can't you input? Which is what you were getting at. You can't input 0, right? If you try to input 0 here, you get error, right? 1 over 0, undefined. That's why you see this, and that's what I think both of you were getting at. It's avoiding it. It will not get 0. That's why you cannot get 0. That's why you get this horizontal asymptote, y equals 0. You cannot get 0 out, and you cannot put 0 in, right? If you graph this one, this is the input right here. What kind of translation is this? If this is the input, where did it? Horizontal. Where did it go? Right 7. So, if I want to track this, let me show you how I do this. I have my vertical asymptote at 0, and I shift it 7. So now it's at 7, and I have my vertical asymptote. Did my horizontal one change? Did I shift it up or down? No. So it's still the same. All right, so there are my asymptotes. And my graph looks exactly the same, except that it's been shifted right 7. Now does it make sense? Again, why is it avoiding x equals 7? Right? You can't input 7. You get 1 over 0. That's an error. Make sense? What happened to this one? Yep, up 1, shifted right 7. You got it. So again, the graph of this one would look something like this. The horizontal one went up 1. The vertical one went over 7. So that means my graph would look something like this. And if you graph this on Desmos, that's what you should have seen. Good? Okay. So these are really important, especially these terms, asymptote, 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 asymptote. So here's a couple things you need to have down. Rational expression, what is it? How do you simplify one? Undefined. Okay? So you need to have those things down. Just from what it says, rational expression is a quotient of two polynomials. Polynomial 1, polynomial 2. It's a quotient of two polynomials. How do you simplify it? Well, I highlighted the important words for you. You factor, you cancel, and then you multiply. Factor, cancel, multiply. Those are the steps you're going to see today. They don't make sense right now because we have to see a problem first. Undefined. We talked about that a second ago. Those are certain x values you can't evaluate at. Right? Undefined, look for when denominator is equal to 0. Undefined. Here are some symbolic expressions of what a rational expression is. 1 over x is a rational expression. Polynomial. 1 is a polynomial. X is a polynomial. Somebody make up one more for me. Make up a rational expression. Make one up. Doesn't have to be right. If it's right, I'll just tell you it's wrong. 2 over x. 2 over x is definitely a rational expression. Give me one more. Make it more complicated.
2 billion over x.
Why?
How about just x squared minus 2x plus 100 over x cubed minus 1. Polynomial, polynomial, right? You don't need to work with super big numbers right now. Just to have an idea of what these are. Polynomial, 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 polynomial. All right, ready to go on?
Like the next one?
Well, yeah, now we're going to do some examples. I'm just going to reiterate this one last time. Factor, cancel, multiply. That's going to be our steps. Okay, so here's our example. Let's do one of these. Simplify 4x minus x squared divided by x squared minus 2x minus 8. So simplify that and also identify x values for which the expression is undefined, which is the key vocab word. You need to know what I mean when I say that. Well, our steps were factor. So I'll do that in blue. Let's see. And this is why I signed that sheet last night, so that you would have done it. I can factor the top one as x times 4 minus x. I can factor the bottom one using mental math, what adds the negative 2 and multiplies the negative 8. X minus 4 and x plus 2. Factor, cancel. I'm going to try and cancel something here. What do you think? Which ones am I going to try and cancel? This can cancel somehow. I just have to manipulate it a little. So let's do that. I can pull out a negative from this guy. This is equal to x times negative 1 times, I factored out a negative 1 from here. So this negative x now becomes positive x, and this positive 4 now becomes negative 4. I factored out a negative 1 from both of those. You see how that works? Negative 1 times x is negative x. Negative 1 times negative 4 is positive 4. I factored out a negative 1. Leave the bottom because we don't need to do anything there. And now I can cancel. Factor, cancel, cancel. X minus 4 cancels with x minus 4. That was step 2, cancel. Step 3 was simplify. Well, on top I have negative x. And on bottom I have x plus 2. If you can't factor, you're having trouble right now. But if you can factor, this should make sense. There's one thing that I want you to mark also that you cannot do, that some of you are going to try to do. And I would mark this down. You cannot do this. You cannot cancel these x's. So you can't do that. If you're going to try and do that, that is wrong. You should mark it. You cannot do that. So you cannot do that. Okay, identify which x values are undefined. That was the second piece. Look back here and tell me what two x values I cannot substitute into that expression. It's really easy if you look back here. Negative 4 is fine. I can't substitute 4 in. 4 minus 4 is 0. I can't substitute in negative 2. Negative 2 plus 2 is 0. So 4 and negative 2. X cannot equal 4, and it cannot equal negative 2. Do you see why? Okay? If it doesn't make sense, just try and go back, plug them in. 4 squared is 16. Minus 2 times 4, that's minus 8, so that's 8. 8 minus 8 is 0. Can't divide by 0. Same thing will happen for negative 2. Good? Okay? So this one, give it a try. Factor, cancel, multiply. Sorry. Factor, cancel, simplify. You try it. And think about where you're getting stuck so you can ask a question. What adds to 1 multiplies to negative 2. Looks like x plus 2, x minus 1 for the top. What adds to 2 and multiplies to negative 3? Looks like x plus 3 and x minus 1 for the bottom. Agree? Yeah. Cancel. X minus 1 cancels with x minus 1. And we're left simplifying with x plus 2 over x plus 3. Good with that? State the x values that we can't substitute back in. Not negative 2, actually. Only looking down here. Negative 3 and positive 1, yep. X cannot equal negative 3, and it cannot equal positive 1. When I'm trying to say what x cannot be, I'm only looking in the denominator. Okay? Questions. It's really important that you ask questions today because this is the foundation for the whole unit. Yeah?
Wait, so how do we figure out what?
You look at the denominator. Neither of these can be 0. What would make this one 0? X is equal to negative 3. Right. Cool. Another question. Really important that you ask questions today. So, get stuck. Need to ask. I think there's one more on this page. Nope. Then let's make one up. You guys are my top class, so you should be able to handle this. Let's see. Let me make one up real quick.
That's rough.
Okay. So try and factor or simplify this guy. 2x squared minus 5x minus 3 over x squared minus x minus 6. Do the same process. Factor, cancel, simplify. If you did this, you're making a mistake. Oh, negative 6, positive 1. So it's x minus 6 and x plus 1. Why do you have to be careful?
Leading coefficient.
Right, that leading coefficient. So you need to do factor by grouping. So factor by grouping, 2x squared minus 5. Oop, what did we say? Negative 6 and positive 1. Minus 6x plus 1x minus 3. Let's see. Factor out 2x. What's left? X minus 3. I can factor out 1 from here times x minus 3. And now I see that it's 2x plus 1 times x minus 3. Good? Okay, so how many of you, be honest, how many of you got to this step right here? Were able to factor that? Okay. If you cannot, you need to focus on this skill. This is going to show up again and again. You need to focus on a greater than 1, not equal to 1. So this factors into 2x plus 1 times x minus 3. Bottom factors into x, x minus 3, x plus 2. Thanks for that. Cancels. 2x plus 1 over x plus 2. Good? Things that won't work. Positive 3. Negative 2. Yeah? So if you're having trouble with this part, this is what you need to focus on. A factoring. Everything else is not so hard. Okay, last couple we're going to do for today is about this. Make sure you copy them down correctly, because the numbers, I don't know, there's a lot of them, you can kind of get them mixed up. It looks complicated, but if you factor, cancel, simplify, it won't be too hard. Can you factor anything? No. There's nothing to factor here because all these terms are just singletons, right? Monomial, 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 monomial. Don't need to do that. Let's multiply out. Multiply, or I'll just say for this one it's either multiply slash cancel. Because for some of us we're going to need to multiply to see that things cancel. Well, 3 times 10 is 30. X to the 5th times x to the 3rd is x to the 8th. Y to the 3rd times y to the 4th is y to the 7th. 2 times 9 is 18. X cubed times x squared is x to the 5th. Y to the 7th times y to the 5th is y 12th. Multiply. Now we cancel. There's a faster way to do it, but 30 divided by 18, well, if you think about it for a couple minutes, you'll see that 6 goes into this and 6 goes into that. So this is, yep, 5 over 3. Subtract exponents, 8 minus 5, so I get x cubed. 7 minus 12, so I get y to the power of negative 5. Don't erase if you wrote this, because this is also correct. 5x cubed over y, 3y to the power of 5. Both of these are correct. How many of you have one of those? All right, good. Do you have any questions on this one? Huh? Okay. Well, then try something a little bit harder. Same process. Factor, multiply slash cancel, simplify. You look at that guy for a second, you'll see this factors into 4 times x plus 5. If you look at that for a second, you'll see that this factors into x plus 3 times x minus 3. Now, cancel. Nope. Minus 3, positive 5, positive 5. Here's something people are going to say. There's nothing left in top, so that means it's 0, right? Right. It's 1. Okay? There's 1 left on top over 4 times x plus 3. And there's your answer. Could also be 4x plus 12. That's the same thing. That's fine. Again, why is it important to factor? Well, what are all my undefined numbers? X equals -5, -3, 3. That's a key idea today. Why it's important to have it factored. All right, one last one, and then I will tell you the homework. Try this one, compare it with a friend, and then say, I'm right, you're wrong. Okay? So check and see if they got it right or if you got it wrong. And try it on your own. Last mistake I might see is I see x minus 1 and x minus 1, x minus 1, so they all cancel, right? No. That's improperly using properties of exponents. 2 minus 1, there should be power of 1 left. Everything else cancels except for x minus 1 and x plus 2, so you're done. If I asked you for the undefined terms, x equals 1, -3, +2. Good? Oh, -2, correct. Yep. Very good, very good. All right, so any questions? Anything you're having trouble with? Again, this is the foundation for chapter 8.
Can you show me how to get 3 of those instead of just 2 ones and another one?
3?
Yeah, so after you multiply those and you factor them, how you got 3 things in parentheses?
Down here?
Well, either one works.
This one is x plus 3. This one factors into x minus 1 and x minus 1. One adds the -2 and multiplies to 1.
Okay.
Yeah, so that's what we're doing. We're factoring this. Same thing. One adds to 5, multiplies to 6, 3, and 2. So if you're having trouble factoring, that's what you need to focus on right now. Yep.
Where's the x squared go?
X squared is hidden right here. If you expand this, x times x is x squared. X times 2 is 2x. 3 times x is 3x. So 2 and 3 give me 5. 3 times 2 is 6. Right? That's what factoring is all about. It's taking this long thing, right, and condensing it down into that. So here's the homework. I would practice it tonight. And again, this is the bare minimum, right? This is what you need to do. You can certainly do more. 8, 2. I don't know what page it is, but it's 8, 2, and it's number 2 through 10. How many problems did I assign? 8. Did I assign 8 or 9? It's 9. Here's the trick, alright? 10 minus 2 is 8, plus 1 is 9. I assigned 9 problems. It's a computer science trick, so. Well, some people will say 8, you know? Some people say 8. Me too. So take a look, see if you have questions. We've still got 8 minutes left. Happy to help you out if you're struggling. Yep.
Is there a way you could ever factor 10?
Say it again.
Is there a way you could ever factor 10?
Factor 10.
Yes.
2 times 5.
Okay, is there a way you could factor like a monomial?
A monomial? Yeah, so if you have
Y to the power of 5.
if you have something that could be broken down, right, like 80, 81, oh, that's 3 to the power of 4.
What about something like y to the power of 5? How would you factor that?
Y to the power of 5, you can't factor it because that's as simple as it can be.
Is there a way to factor and make it less simple?
A way to factor and make it less simple. Yeah, sure. Notability? Let me see. So y to the power of 5. Y to the power of 5 equals y to the power of 25 over 1/5. So, right, calculate the exponents, multiply 1/5 of 25 is 5. Now this one complicated. So,
You just proved to me that factor is unnecessary.
no, this is already, you can't factor this. This is just called being silly, complicating things.
So factor equals considered.
No.
That's